Greetings to you. We are here with you for another session of electronics training. And in this session, I want to show you a few resistors of the variable resistor type and the testing method for these types of resistors as well, so you can learn how to test them. The first resistor I want to talk about is the potentiometer resistor, which looks like this right here. As you can see, this type of resistor is mostly known as a volume control, and these resistors are used in volume controls for various devices. The ohms of these types of resistors are either like this, as you can see here, printed on this part, written, or on the back of the resistor, placed right here. And these volume controls or variable resistors come in various ohms, and you can buy them in whatever ohm you need. For example, you see 500K written here, which means 500 kilo ohms. So this means it's a 500 kilo ohm variable resistor, and you can easily get 10 ohm, 5 ohm, or any ohm you need. Resistors that are like this are called potentiometers. Actually, there are different models. For example, here you see another model where you actually have to turn it using a screwdriver, and you see the number 501 written here. And if we take this next one, the exact same rule for calculating resistors with numbers applies to this potentiometer as well, where it says 501. If we count this one as another 0, it becomes 500 ohms. So this resistor is a 500 ohm resistor, meaning it's not even 1 kilo ohm. This is a 500 ohm potentiometer. And let's bring in another potentiometer. For example, here you see it says 103. You see, this is another model of potentiometer. It has the number 103 written on it. This number 3 means 3 zeros. This also becomes 10 with 3 zeros in front of it. It becomes, 10 kilo ohms. Because it's 10,000 ohms, right? And every 1,000 ohms is 1 kilo ohm. So this is a 10 kilo ohm potentiometer, and they are placed here in different forms for you to see. Now, what is the testing method for these potentiometers, and how should we test them? I want to explain further so you can learn how to test them in different circuits. The first sign of a faulty potentiometer, or the volume controls you see here, is when it's installed on a device and for example, our device has a volume control for a radio or a volume control for a recorder. You want to turn the recorder's volume up or down, and you see instead of the sound increasing or decreasing smoothly, it jumps and makes a lot of crackling noise. When you turn the volume knob, the sound has a lot of crackling and it jumps up and down. It either gets very loud or very quiet, and it can't find a middle ground to observe. This is the first sign that the potentiometer or the volume knob has failed, and you'll need to replace it. In many recorders and devices used for, say, audio output or even amplifiers where a volume knob is used, and they pretty much all have one, the main reason for sound skipping and crackling. Crackling sound is always a faulty volume knob or that resistor that's positioned right here like this. What you do is you remove the potentiometer from the board and replace it with a new one, and make sure it has the same ohm rating as the one on the device. So that's the first type of failure. Now there's another type of failure that might actually make diagnosis difficult sometimes, and you might not be able to correctly determine if the potentiometer is broken or not, or the volume knob. This is where you can very easily actually test this potentiometer using a multimeter. Now, what is the internal structure of a potentiometer like? Next, I'll first explain its structure so you know how to actually test it. Look, as you can see, whether it's this model or this model that you see here, they all have 3 pins. I mean, mostly on different boards, they have 3 pins. Okay, now how should it be tested? It depends on you knowing exactly what its pins are like and how to look at them. The middle pin is always used as the input pin, although you can also use it the other way around, meaning you use the side pin as the input and the middle pin as the output. In this case, it doesn't matter, because a resistor is actually a two-way component, and it doesn't matter which direction you use it in. Let's assume that the middle pin is the input pin, and the end pins are the ones you should use as the output. Okay, now what does that mean? And how does it actually work? The internal structure of a potentiometer is like what you see in this image. Look, here you see it shows the internal structure of the potentiometer, and inside the potentiometers or volume knobs. See, there's a strip like this, which is actually the strip that contains the resistive material and has an ohm rating, meaning the resistance of this part is different from this part. When you turn the volume knob like this, as you see in the image, this wiper moves on this pad, the resistive pad that has different ohm values, and the further away, for example, this gets the ohm value between this pin and the middle pin increases because this moving part is connected to the middle pin. Now, the further the distance between the middle pin and one of the end pins, say this pin, the more its resistance increases, and from 0 up to the maximum ohm value written on the resistor, you will have that resistance. And the less the distance between the middle pin and either of the side pins, the less the distance. As you can see here and in this image, its ohm value will also decrease and become lower. So this means that if you take this potentiometer, for example, if this is for the middle pin and you go place it here, what happens to the connection between this pin and this pin since it's at a closer ohm? It has a lower ohm, and the more you move it towards the maximum, the ohm value of these two pins actually increases, and it will be the same for these two pins as well. So the middle pin is directly connected to the part that rotates and moves on the pad, and this way you can use this resistor. Now what you do is you set the multimeter to a specific ohm value. Now what do I mean by a specific range or ohm? Look, it's written here, 500 kilo ohms on this potentiometer. Now to test this potentiometer, you must, let me turn on the multimeter first. You must set the multimeter to a higher range. For example, I've set it to 2 mega ohms here, which is much higher, and then what do? You test the potentiometer or volume control using the probes. It doesn't matter. You place the black or red probe on the middle pin and the negative probe on one of the ones you want to test. Here, it shows me the number 120, about 120, meaning it has 120 ohms. It's showing me. Now, if I turn this volume control, you see that the ohms increase to the point where it even cuts off, or it decreases. Now, if I want to test it more easily, I'll use these cables. I'll connect one of the cables here to this pin, and I'll connect another one to the middle pin. This way I can test it more easily, and I'll connect the other end of the cables to the multimeter. Well, you see that here it shows me the number 300, about 340 ohms. It's showing me. Now notice that no matter how much I turn this potentiometer, you see that the number gets higher and higher. If I turn it back, it decreases, reaching its lowest ohm value here, meaning the ohm is 0. And now if I turn the potentiometer slowly, you see that the ohm value keeps going up. When you turn the potentiometer like this and you see regularly that its ohm value is changing and increasing, this proves that this potentiometer or volume control is actually healthy and has no issues, and you can use it. But if in this type of test you see that, for example, when you turn the potentiometer nothing happens, or the number is constantly 0 like this, and then, or for example, it shows very random numbers with no pattern, or it's completely 0 in any position, you set it to, it's always 0. Like this, it indicates that the potentiometer or volume control is broken and you must replace it. But when you connect it, you see that like this. Look, as I turn it very slowly, it shows the ohms steadily increasing. This means this potentiometer is healthy, but note that this healthiness only applies to this pin and this pin, meaning the middle pin and this end pin on my right. Now, I must do the same test with this other pin to be sure this potentiometer is 100% healthy. I'll connect the middle pin again, and I'll connect another probe to the end pin like this. And I'll go ahead and repeat the same process. This time, turning it the opposite way, the ohms should decrease, or decrease and then increase in the forward direction, see? It's showing me the ohms very easily. Now, as I increase the distance, the ohm value goes higher. It's very clear that this potentiometer is perfectly healthy. But if you see any other state, for example, if it's disconnected or constantly at 0, since I've set the ohms to the lowest now, it's 0. I can turn it up a bit and let it stay at a higher ohm setting. For instance, I'll increase the ohms. When you see that in any position, the ohms of this potentiometer is 0 and doesn't change. Or if the connection is broken, like if it shows OL, meaning the multimeter looks like this, it means that potentiometer is broken. Or if it's on a device and you see the volume jumping as you adjust it, that's also a sign of failure. But the testing method I taught you here is one of the standard and fundamental ways that you can very easily test a potentiometer like this, as you've learned here. So definitely keep this in mind and test potentiometers based on this. Now let's move on to another potentiometer, a smaller type, to see how this potentiometer performs. The function of this potentiometer is exactly the same as I explained in the image. And the middle pin, which is this one, is connected to the other two in the same way that was explained. Once again, I'll take one of the probes to the middle pin and the other to one of the end pins. You see that it's showing me the ohms here. Now, to see if the ohms of this potentiometer are correct and it's working right, you do the same thing. You go ahead and, using a screwdriver, turn this opening to see if the ohms actually increase or decrease steadily or not. For example, I'll go ahead, and to let you see better, I'll secure the pin connections more firmly so they don't fall off, and I'll use a screwdriver to turn the potentiometer's dial and see what the multimeter shows me. You see, as I change it, the ohm level slowly starts to increase. See? This means this potentiometer is also healthy and has no issues. And just like that, you can easily test both types of potentiometers of any kind and any size very easily. One example was like this. Another example was this one, which you'll see a lot of on electronic circuit boards. And there's even this other type, as you can see, which is a vertical model. Another example is this one that you can see right here. These are very common examples that you'll come across. And another way to identify a potentiometer, since they fall under the category of resistors, is that you should pay attention to the label next to the component on the board. If you see a component like this on a board with an R written next to it, that means it's a potentiometer. Because we also have variable capacitors that look very similar to potentiometers. To avoid confusing them, it's simple. If it's labeled R, it's a potentiometer. If it's labeled C, it's a capacitor. Anything other than C or whatever else is written means it's not a resistor. Only R stands for resistor. So by now you've learned how to test a potentiometer and you know how it's done. So just remember. First, measure its resistance with a multimeter. It should show the maximum and minimum resistance, and when you turn the dial, the resistance should change. Just like you saw on the multimeter here. But if you see there's no connection or it doesn't show the right resistance, that means it's faulty and needs to be replaced. Potentiometers aren't really repairable. You definitely have to replace it. Remove the part and put in a new one. That covers the potentiometers that can be adjusted by hand.